Steam-assisted gravity drainage, or SAGD, is a specialized extraction method for the recovery of heavy oil in a sand formation. Known as tar sands oil, the oil is not able to flow easily because it is dense or tar-like and must be heated. This form of steam stimulation requires that two horizontal wells be drilled parallel, one above the other. The lower well is the first of the two parallel wells to be drilled. It will eventually become the producer well, which will pump oil to the surface. The vertical sections of the wells are drilled to between 250 feet to almost 2,000 feet, depending on the depth of the targeted formation. Once the first well is drilled, the drill pipe and bit are removed. Next, a larger diameter pipe called casing is inserted into the well bore and cemented into the hole. The cement provides stability to the well bore, which must withstand constant steam temperatures as high as 500 degrees Fahrenheit. Additionally, the casing and cement create a barrier that isolates the well bore from the underground fresh water, preventing possible contamination. Upon reaching the point where the well will be drilled horizontally, it is then drilled from 1,000 feet up to 3,000 feet into the reservoir. Once the casing and cement are in place to the heel, or point where the horizontal section of the well begins, a smaller pipe with slots in it, known as a slotted liner, is inserted through the casing pipe and to the end of the horizontal well bore. The liner in the lower well bore will be the conduit through which hot steam will be injected at the beginning of the process, and eventually the oil produced through. The slots allow the steam to easily radiate outward into the surrounding formation and will create what is known as the steam chamber. Once the slotted liner is in place, the first well is completed. The drill rig is moved to begin drilling on the second horizontal well, and a wellhead is installed on the first well. Next, the upper well, known as the injector well, is drilled using the same process as the lower producer well. This well is drilled above and precisely parallel to the producer well bore. Careful positioning and separation are maintained between the two wells, which are spaced approximately 15 feet or more apart. During this time, the surface facilities that are required for the SAGD process are built on location. These include steam generators, separation systems, and storage tanks. The water stored in the tanks is typically piped from underground aquifers or a nearby lake or river. Natural gas is most commonly used to heat the water for the steam generators. Initially, steam is pumped into both wells for a period of 2 to 4 months. This time is necessary for the steam to gradually reduce the viscosity of the heavy oil. As viscosity is reduced, the oil becomes less thick and is forced from the sand in which it is embedded. Because the steam rises, even below ground, the steam chamber begins to form in an area between and above the two well bores. Once conductivity is established and the heavy oil begins to separate from the surrounding structure, only the upper well continues to inject steam into the steam chamber. The steam rises to the ever-growing outer edges of the steam chamber, where it begins to cool and then condense. Gravity directs the heated oil and water downward along the boundary of the steam chamber, where the combined mixture is collected by the producer well and pumped to the surface to be separated. Over time, the steam chamber will continue to grow outward and upward, maintaining a characteristic triangular shape. The injector well continues to pump steam into the reservoir, while the producer well recovers the once inaccessible heavy oil. The water that is produced along with the oil is separated, cleaned, and then recycled for new steam generation. This process is perpetuated from several months up to several years, until the amount of recovered oil begins to decrease.